Alright, so this is the recorded answers to lab number 6. Question number 1 is simply find the marginal productivity of the inputs, and as long as you know that you have to take the partial derivative and to find the marginal productivity of the input, and you know how to take partial derivative, you should be okay. So for instance, the first one, marginal productivity of capital, is going to be the partial derivative of q with respect to k, and that's going to be equal to 1. The second one, marginal productivity of capital, is going to be equal to 2k, let me write the whole thing here so you don't get confused. It's partial q with respect to k, and that's going to be equal to 2k minus 0.5 L. Now in this third one, the marginal productivity of capital, in this case again it's partial q with respect to k, and it's going to be equal to 1 times whatever is labor, so that's going to be 5L 0.5. And the L that is actually to the right of the negative sign, you don't count that because that's the power of k. Okay, in the second part, you remember that I told you to use the one for C above and not B, and that's Q equals 5L 0.5 K minus L. Now if K equals 2, then Q equals 10L 0.5 minus L. Now you take the, to get the marginal product of labor here, you take the partial derivative of Q with respect to L, and that's going to be equal to 5L minus 0.5 minus 1. Now you make that equal to 0 to find out level of that, and if you do that, then L equals 25. So that's the level at which MPL equals 0. Now for this problem here, the only one that I'm going to be making responsible is part A. Part B, you have to use the quadratic equations. Don't worry about that one. But part A, it's important because it's going to give you a little bit of an understanding of MPL. So it's looking for the point at which MPL starts decreasing. The maximum, the mini chain returns when the marginal product of labor start to go down. Well, the first thing you need to know to find the marginal product of labor, and you know that that's the derivative of output with respect to labor. In this case, it's going to be 100 plus 100 L minus 9L squared. And you want to find the point at which that equation starts to decrease, the maximum point of that equation. So you're going to have to take the derivative of that equation, which is MPL, with respect to labor, and that's going to be 100 minus 18L, and make that equal to 0. And you find L equals 5.6. Okay, so that's the point at which, if you have L here and MPL here, this is this point right here, right? So this point right here, L equals 5.6. All right.